Hey, good morning or good afternoon, wherever you are. But thank you so much for registering for the first of six HVAC controls fundamentals classes. Today's class, which we're excited to present, is Controls Basics. A few just housekeeping items before we get started. One, for all the latest news, definitely follow us at our Distech Controls Instagram page and follow us on LinkedIn as well. We're planning to have these be 30-minute quick sessions. So Grant, my co-presenter, and myself will be presenting for 30 minutes. Please don't hesitate to ask any questions in the questions tab. Also, we are going to be emailing out a PDF of this presentation at the end, so you can refer back to it. And again, just don't hesitate to ask each and every question that comes to your mind. No such thing as a stupid question. We want to build a team, a next generation of controls ninjas out there. And my name is Stephanie Shahowski. I am the regional sales manager for Southern California for Distech Controls. And presenting with me today is Grant Butler. Go ahead, Grant.
Hey, how's it going, guys? Yeah, my name's Grant Butler. I work out of the New York City region. And like Stephanie said, we're really just trying to start this with the basics, and we'll build up through these 6 control sessions that we have. So one added housekeeping note that I want to point out is the first 3 sessions were registered as a combined 1.5 continuing engineering credits within the state of New York. So that should be pretty useful for all those engineers that are joining us. You do have to attend all 3 of those sessions to get credit. There's no partials for this. So the sessions are controls basics, communication protocols, and MSTP versus IP. So if you're able to make those 3 and you're within attendance, we'll be able to send you over a certificate for those credits. So with that, I'll go ahead and jump into it. So here's a high-level agenda for us for today. This session is very introductory. We're starting off with just comparing standalone versus BAS and running through inputs and outputs and unit level controls. So I think it's really good to start off with standalone versus BAS control. With that, you're able to really compare what functionality you're getting out of a BAS system. So standalone control functionality is quite limited in the setup. It's usually meant to just be set up for an individual piece of equipment, not very scalable and not the most energy efficient option that you have out there. So a standalone control could be something such as just a single zone rooftop unit being controlled by a thermostat. If that's not networked into the rest of the BAS system, that unit will operate standalone, and it will operate as good as it can based on the information it has available. It's not able to collect feedback based on water temperatures, how your plant's operating, work with VAVs or anything too complex. So that's what you're looking at with standalone control. With the BAS system, building automation system, you may also hear building management system, BMS, EMS, energy management system. All those are the same thing that we're talking about here. They're systems that are networking together controllers within your building, networking together multiple pieces of equipment so that you can look to optimize how those pieces of equipment are working within that building. So you're looking at both energy efficiencies and also operational efficiencies. Not running from room to room, changing thermostat set points is a really big added advantage for your facilities team that's on staff. So with that, let's go ahead and jump into what really goes into a BAS project. So there's 3 main categories that it gets broken down into. That's electrical installation, which so electrical installation covers your input output wiring, your communication wiring from controller to controller. The input output wiring is just wiring to sensors, valves, actuators, all those different control devices, COM wiring between controllers. You can have power wiring as well. BAS manufacturers sometimes need to be powering up their panels for their controllers, their controls. And you need to consider with that the different types of wiring requirements that you have. So when wiring in mechanical rooms, you would probably want to put that in conduit to protect that wiring. Also outdoor wiring, you'd look at rigid galvanized steel as a type of conduit that you'd use outside to protect your wiring so that it's not getting damaged by everything outside. The second category is your controls labor. So with your controls labor, you have technicians, engineers, and a PM. So technicians are going to be responsible for programming all these controllers, making sure that they're operating to the sequence of operations that is specified. They're also going to be looking at setting up graphical interfaces so that you can really understand what's going on with each individual piece of equipment or system. Your project engineer is going to create the submittals for the controls team. So that's how we know where everything is getting wired to. And it also confirms that we're meeting the requirements that the engineers laid out within the specs and mechanical drawings. And finally, the project manager is there to coordinate between trades and make sure that that controls project maintains schedule and that everyone is working together with the controls team so that we're able to execute a good, clean project. The final category that breaks down into a controls project is the material. So you have valves, your temperature sensors, humidity sensors, airflow measuring stations, all these different inputs and outputs, and the controllers that are controlling them are going to be part of your materials. But also keep in mind you do have some computer hardware as well. So you're going to be running that through likely a front-end PC, and that's what your facilities team is going to be looking at to operate that BAS system and maintain the control they're looking for. And you can also have a server if you're looking to bring in and aggregate more data within that BAS system.
Furthermore, as more and more folks are installing IP-based controls, you would also see like network switches potentially included, provided by the BAS contractor, and those can be either DIN rail mounted or rack mounted. So that's something we're seeing BAS contractor provide more and more these days as well.
Yeah, absolutely right. Thank you, Stephanie. Good point. So overall, these are the three main categories that you're going to be looking at for a controls project. This is what it all sums up to. Electrical installation can be a big chunk. I know for me in New York City union labor electrician rates are pretty expensive. So that cost can represent anywhere from 30 to 70%, even all the way up to 70% of the overall controls project cost. Controls labor is usually in the 20 to 40% of the overall controls project cost. The materials somewhere in the 10 to 20 or 30%, depending upon the type of project that we're talking about. But that's specific from what I've seen locally in New York City. I think other cities may not have as high of electrical wages, so that could definitely vary a bit. So I like to start off with showing a network BAS system and kind of we're going to build from this drawing that we have here and really help you understand what goes into a control system. So first glance, this drawing looks a little busy, kind of confusing, but I want to highlight a few things, and we'll refer back to this drawing again later in the session and start to really piece together this puzzle of what all is going into this control system. So The lines are meant to represent wiring, either going from one controller to the next or out to inputs and outputs. And then the dashed lines are meant to just signify that that's continuing out to something else. So that could be going out to the control device or just on to the next controller. With that, we'll come back to this drawing. Let's go ahead and move into what are inputs and outputs. I think it's pretty helpful to compare this to human anatomy and physiology. Seems to be something pretty relatable for all of us. So you can compare it back to the human brain and how your body operates, you'll be able to really quickly understand what a controller is doing. So if you compare your brain to a controller, and looking at this diagram on the left, you're going to see that it's putting its hand near a hot stove. And all of your senses, whether that's your sense of touch, your sight, your hearing, all these things are inputs that your brain is able to take in. And then from there, you're able to react based on those inputs. So in this case, putting your hand near a hot stove, you'd have an input from your sense of touch sent to your brain. And then your brain would make a logical decision, which would be move your hand away, it's hot. So that reaction would be the output from your brain. Compare that to a VAV box controller, pretty similar. So we have a space temperature sensor, and that's sending an input to your controller, determining whether or not you're at your space set point that you want to be at. So if you say you wanted that set point to be at 68, and currently the room's reading 70, that controller would then go through logic to know, all right, I should open up my VAV box damper a little bit, get some more cool air into this space, and try to cool back down to our 68-degree set point. So pretty simple. Input from your sensor in the space, output to your damper actuator, which is controlling that box. Want to add anything onto that, Steph?
Yeah, just if you're just starting out and get confused by what's an input, what's an output, just always think, in the perspective of the controller, or go back to, Grant's example about the brain. So that sensor input, your hand sensing hot, would be analogous to the controller, sensing an input like a space temperature sensor or something like that. But yeah, always in the perspective of the controller.
Yep, absolutely. So let's go ahead and break this down a little bit further. So there's not just inputs and outputs, they're broken down into binary and analog. So binary is anything that's two state, on off, one or the other. It's two choices. Whereas analog is something that can vary over time or modulate. So if we started off looking at the binary inputs, that could be anything like a status of a piece of equipment or a leak detection. So I'm really just concerned if there's a leak on the mechanical room floor or within a drain pan, I want to know, is there a leak? Isn't there a leak? So there's two options, and that's an input being sent back to my controller. One thing, a word that you can keep an eye out for with inputs is the word switch, is kind of a ping word you'll see a lot. Switch, status sometimes as well, as signifies binary input you'll see. So pressure switch, airflow switch, any type of unit status, you're going to be immediately thinking of binary input when you hear that.
Right. And you might also see the word digital being used, digital input, digital output, and that refers to the same two-state, on, off, something like that. Also on controllers, you might, if you're looking at a cut sheet for a controller, you might see something like a universal output or universal input, and that means it can be configured to be either analog or binary.
Yeah, yep. So that makes it a little bit easier for where you're landing points on a specific controller. With those universal points, you could land either analog or binary there. It's just easier in the field for wiring up a controller. So looking at binary outputs, this is things that just start, stop, open and close, two position, enable, disable, staged control. So it's just turn on one stage, turn on the second stage. Those are all examples of binary outputs. It's being sent from your controller to a control device and signaling two options. From there, we have analog inputs. So analog inputs are everything that you're looking to sense within a building. So that could be your temperature, humidity, pressure, airflow. We have a few others here, even something like people counting. You know, these are all things that can vary over time, and they're inputs to your controller. And then finally, in terms of analog outputs, the key ping words that you're looking for here are modulating or speed control. Those are analog outputs. So controlling the speed of a fan or modulating a valve or a damper actuator. Those are being sent from your controller to that control device. So I think it's good to look at a fan as a very simple way to break down what input and output points you'd be wiring to a fan. So if I want to control a fan with just a basic motor starter, all that I'm really going to be doing is starting and stopping that fan and then monitoring the status. So starting and stopping would be a binary output, and then status is just a binary input. I just want to make sure I know if that fan's running or it's not running. In terms of a VFD, there's a little bit more that you can do with that. So over here on the right with the VFD, you can also now start to modulate the speed, get some better energy efficiency out of this fan, not just always be running it at the highest speed. So you'll start the fan with a binary output, and then you'll modulate its speed with an analog output. So start to modulate that speed. You can still monitor its status. And there's a few other points that you could look at in terms of hardwired points with the VFD. You could look at feedback, analog input, or fault, binary input. Ultimately, there are more points that you can monitor with a VFD if you were to bring a COM connection to it. And we'll talk a bit more about bringing COM to VFDs in a later session, but this is good examples of some hardwired points you'd have from a fan. So looking through now, let's take a look at a full piece of equipment and try to better understand what all inputs and outputs you'd have there. So here's an air handler. We have some temperature sensors, humidity sensors. We're running these fans, so we need to have these probably have VFDs, so we'd have 3 points for each of those at least. Controlling some valves, some actuators. Stephanie, there's something else a little bit interesting in this drawing where my mouse is at. You want to talk a little bit about that?
Yeah, so especially relevant today in the times of this pandemic and crazy coronavirus times where we're dealing with. So historically, we've seen UV lights, which that is what Grant is referring to, used to potentially keep a cooling coil clean, preventing the buildup of debris and mold and other organisms. But today, the UV light could be used to kill similarly bacteria, mold, viruses within the airstream.
Yeah. So that could be another piece of that air handler that you'd be controlling as well. So ultimately, what you're doing here is you need to control quite a few variables in your building. So it's not just temperature; it's a lot more than that. To make a comfortable and safe building. So temperature, humidity, pressure, air movement, and making sure you get those proper air changes, a lot of good ventilation within that building are all very important to have a comfortable building and make sure that it is a safe environment. So let's take a look at how a controller logically works to maintain the parameters that you want. So all these different variables that we're trying to maintain. The controller utilizes control loops to try to maintain these variables within a building. So starting with a simple loop, we can just look at a discharge air temperature loop. So if we were trying to maintain this 17 degrees Celsius discharge air temperature, we'd be modulating these valves on the heating and cooling coil as needed to hit that discharge air temp. It looks like here it's doing some heating to maintain that discharge air temp. But there's a little bit more going on with this air handler. You may want to be bringing back some mixed air. You want to, in which case you have outside air coming in, return air coming back. And anytime you're bringing in outside air, you're going to have to usually account for some more mechanical cooling or mechanical heating. So because that outside air needs brought back to the set points that you're looking to work with for the rest of your building. So obviously bringing in that outside air has an impact on the rest of the loops that are operating here. But you can't just only account for one thing. You got to account for them all. And the final one that we're looking at here is just pressure. So with pressure, if we don't want doors billowing open or being sucked shut within our building, or if it's a hospital, somewhere where you really need to have controlled pressure spaces, either way, you're going to be looking at your fan speeds and modulating them such that you have a positively or negatively pressured space. So all these different loops kind of build on top of each other. You change one, it affects other variables. They all kind of work in tandem. That does seem a little bit confusing, and that's why I have my little Seinfeld reference here. But don't worry, ASHRAE does have a lot of standards set aside for us controls teams to work with to make sure that we're having all these different parameters work together in an energy efficient manner. Do you have any questions so far, Stephanie?
We have, let's see, we have a couple questions if you want to maybe go back a slide to the air handling unit diagram. So we have two questions here. Can you give us an example or two of what devices might be used to sense fan status?
Yeah, so one thing you could do is you could put a current switch at that VFD. And so that's just pretty much measuring whether or not you have power going to that fan. Another option would be you could put a airflow switch across that fan on either side to actually detect whether or not there's air being sent through. So it's just it's determining pressure on either side of that fan.
Yeah, similarly, and I think you kind of answered the follow-up question we have here, which is, what's the difference between a binary airflow switch and an analog airflow input?
Yeah, so the switch is just telling you, is there airflow or isn't there? You kind of put it at a set point, maybe you say, if you see this much CFM or this pressure amount, that's going to signify that there is airflow. Whereas airflow sensor is telling you the exact reading of it. So you're going to say, okay, I have 800 CFM flowing through that airflow sensor. So it's going to give you the exact amount.
Let's see, here's a good question, Grant. What is the utmost most important thing to remember when dealing with inputs and outputs on air handling units?
Utmost most important thing to remember when dealing with inputs and outputs on air handling. I think there's multiple answers to this. I'm not sure if there's something you think it's driving towards, that question towards.
I'm not sure, but what I would say is, you know, I always liked when I was pricing up projects that there was a clean points list, which helped me kind of be able to determine what type of controller to use. So if you don't like outline all the points you think you'll ultimately use, the controls contractor might price up like a smaller fixed point controller, And then if there's any changes later that require more inputs and outputs, they might have to then, ask for a change order for a more expensive controller that accommodates more points or that's modular in nature. So I would say, controls contractors, we love the points list, and I think it just makes for a more successful project.
Yeah, I think that's a good point. Having a modular controller in place that allows for spare capacity is very good for something like an air handler. Usually, a lot of times with an air handler, you're probably going to want your controls contractor to provide the controller themselves rather than it be a factory packaged control, unless you really know what's going on there out of the factory.
Yep, and we'll talk a little plug for Thursday's session where we talk about communication protocols and open systems. But another important thing for the question on what's the most important thing, also understanding, if you're connecting to VFDs, if they're also communicating a protocol like BACnet over MSTP, or if you're connecting to meters over Modbus, so that can be factored into the controller selection as well. But we'll get into more of those details in later sessions.
Yep. Okay, let's go ahead and jump ahead here. So where you'll find all this documentation, not only on the mechanical plans, but within the specs, you're going to be looking at 230900 section, which is going to house all the details on the controller types, the inputs, output control devices, computer requirements that you need, wiring requirements, training time, all of that is going to be within that 230900 section. And then your sequence of operations is where you're going to actually deep dive into each individual piece of equipment and explain how that piece of equipment should be controlled. So that's where you're going to run through all the sequences for the piece of equipment. Hopefully you could find a points list within that sequence of operations, as well as Stephanie alluded to. That's definitely very helpful from controls perspective on pricing up a job. So let's go ahead and move into unit level control. The unit level, what you're really doing here is you're taking all those inputs and output devices and you're landing them onto a controller, and every single piece of equipment, whether it's a fan coil unit, a VAV, an air handler, they all are going to have a unit level controller. And that's where you're going to wire all those input and output devices to. So your sensors, your valves, your actuators are all going to go to that unit level controller. And what that does is it allows for you to have safeties, alarms, and diagnostics locally at that piece of equipment. So you're not going to have compressors running rampant, anything like that. That local controller is there with its safeties integral to it to make sure that equipment's operating is in the right fashion. And then finally, if you were to lose communication with the rest of the BAS, this controller will allow that piece of equipment to operate in the most efficient manner it can based on the data it has available. So continue to operate. Probably won't be as efficient as whenever you have it networked with the BAS, but it will still continue to operate that piece of equipment. So let's look at a VAV box like what we have here and just show how simple this really is. We do have a few extra points on this particular VAV box, but I'm just going to hit on the main points you're needing to control a VAV box in typical situations. So you have a space sensor, and this is going to be, detecting your temperature. Maybe you have humidity, some other things in your space you want to keep control of. You're going to be monitoring the airflow coming into that VAV box and controlling a damper actuator. So controlling that damper to allow more or less air into the space to try to achieve the space temperature set point that you want to be hitting. With that, some other things I want to point out here is this Ethernet Cat5 connection. So this is connecting this VAV box back to the rest of the BAS. This is its connection point back to the rest of the BAS, allowing this VAV box to communicate with the rest of the network. And finally, some power to this controller. So it does require power something that hopefully will be brought to it by Division 26 electrical contractor. That's what you're looking at. Very simple for a VAV box controller.
Yep, and as Grant said, so in this case, we're looking at specifically an IP, backnet over IP VAV controller. So it is leveraging that Cat5 or Cat6 as its communication. Or in the session on Thursday, we're also going to talk about backnet over MSTP and LANWorks, which are serial communications, which are other methods for controllers to communicate, as well as existing proprietary protocols.
Yep. So I want to break this down back to that drawing that we showed right at the beginning of the session. So now let's try to better understand what we have going on here. Let's start with the green bubbled area that we have. So this blue box here, that's a unit level controller. And then all these red lines are representing input output wiring to different control devices and sensors. So controller inputs and outputs with the red lines. Then finally, this gray line is representing communication. And that's how this controller is networked back to the rest of the BAS. So this could be something as simple as just like a single zone air handling unit that we have here. And it's being networked back to work with the rest of the system. As you can see, we have a bunch of other unit level controllers out there. They all have their own inputs and outputs for that piece of equipment. And they're each networked back to the rest of the BAS as well. So the final thing we wanted to touch on, I know we're just a little bit past on time. My bad, I was running a little bit slow, I guess. Was factory package controls, which I think is a big hot topic for discussion. I do have two fingers pointing at each other because it can become the blame game between equipment manufacturers and BAS contractors. But there are definitely ways to avoid it becoming a problem with factory package controls. You really need to make sure you have upfront coordination so that the controls contractor knows exactly what the equipment contractor is providing and what, if everything isn't being provided, what they need to wire in the field and provide in the field. Typically, you want to stick to using factory package controls for less complex pieces of equipment. And a lot of times for standalone. So something like a hotel, with a bunch of water source heat pumps. All of those water source heat pumps could just come with factory package controls, thermostat, run them in each individual room, and that'd be it for them, rather than making that too complex of a situation. If you don't need all of them to be shown in your BAS, that's an option.
Yeah, and exactly what Grant said, for simple applications, factory package is fine. For more complex, where it might be a complicated sequence, you might be better off using a freely programmable controller, which many times a factory package controller for like a rooftop, it might only come with certain pre-canned applications where it might not be freely programmable or customizable. Yeah,
that's true. You can't wire your toilet flush button to those controllers.
But you can use extra USB port to charge your phone, so.
Oh, there we go. Yeah, so every now and again you get some fun features.
Yes.
So we're gonna go ahead and stick around for the next 15 or so minutes to answer some of these questions that we missed. For those that aren't able to stick around, we thank you for joining, and we'll see you on the next one on Thursday. Just keep in mind, these are going to be rolling out every Tuesday and Thursday, pretty much for the rest of the month. We have 6 total sessions.
Thursday is going to be a great session. It's on communication protocols and open systems. So reviewing BACnet IP, MSTP, LAN, and then discussing what makes the system open. Again, there will be 2 sessions, 8 a.m. Pacific, 11 a.m. Eastern, and then 11 a.m. Pacific, 2 p.m. Eastern. So thank you guys so much for joining. And again, Grant and I are going to stick around for the next 15 minutes, and we are going to start to answer some of these questions. All right, Grant, let's take a look. Here's a good one. What carries more weight, in pricing a project? Plans or specs?
Oh, you're going to look at the plans a lot of times, mainly to be getting your counts. It depends on what's offered on both of them. If you have mechanical plans that someone puts flow diagrams and really detailed control diagrams on them, that can be really helpful for the controls contractor to know what they're getting into. They can physically see what the inputs and outputs are, quickly identify how many pieces of each equipment there is looking through the mechanical plans. So that's going to be very helpful. But whenever you're actually deep diving individual devices, you do still need to know what we're talking about. Are we talking about like inexpensive little airflow sensor, or are we talking about an Ebtron Gold Series airflow measuring station? Those are two completely different cost categories, and you need to usually look to the specs to determine that. Another big thing that's in the specs, or should be in the specs, is your wiring requirement. And like I said, wiring can be anywhere from 30 to 70% of your cost. So you really do need to know whether or not you're supposed to be running the entire job in conduit or not. That could be a big game changer in your pricing.
All right, here's another question. Is the wireless option for Distech, this is a confusing question. The question's on our Distech controllers over IP. Is there a wireless option? And the answer is yes. There are actually 2 USB ports on every single one of our Distech IP controllers. Our IP controller line we call the Eclipse series. There's 2 USB ports on each. One of those can be used for a wireless transmitter. So then the controllers can talk to each other backnet over Wi-Fi. And then you can leverage the other USB port to plug in an InOcean transmitter to pick up wireless devices over InOcean, or even Bluetooth is a third option. Or you can use a USB port to, as we were joking, charge your phone. So whatever. Or add extra memory and storage.
Yeah, there are definitely quite a few ways of doing it. Wi-Fi, InOcean, and Bluetooth are what Distech has within their offerings.
All right. Is there a difference between BAS and BMS?
For all intents and purposes, no. BAS, building automation system, BMS, building management system, you're going to hear those used interchangeably. I apologize if I did that a lot throughout this session.
I do the same thing. This might be hard to quantify, but the question is, how much cheaper are factory package controls?
That is a little bit harder to quantify. It depends how inclusive they are, I guess I would say. If I still have to go to that unit and wire a bunch of points, there's a lot of stuff that still needs to be field wired, like valves, an airflow measuring station, some other things. The more you start to add in a bunch of extra stuff, it becomes less and less of a value add, and it becomes more of a headache because you're now being forced to utilize a different manufacturer's controller, right? So you're gonna have to figure out how to work with that controller versus just one a Distech controller that you're used to working with.
All right, so here's a question, and might need you to go back to the slide with the system architecture grant. But the question is, what are the network switches for in the network architecture? And I can try to explain this one.
Yeah, you want to take this one?
Yeah, so in this architecture we're leveraging a full architecture using IP-based controls. So in your typical or like older generation of controllers where they're leveraging that BACnet MSTP, LonWorks, or proprietary communication. You typically had your unit controllers, or also known as your field controllers. And then you typically have those guys wired up to a building controller or a JACE, a more powerful controller that does more higher level functions, typically has more horsepower, things like that. And that's typically how your building automation system would connect, you know, to the owner's LAN, whereas this building controller would have an IP address, and it's kind of how everything would get connected in the tiered architecture. But in this diagram where we have all BACnet IP controllers, just because there's so much horsepower, processing speed, much of the intelligence is distributed and decentralized, you no longer necessarily need to have that higher level building controller. So now we can just network, we can just daisy chain and tie back all our controllers back just via like a network switch. So like a Cisco switch or an Optigo switch, something like that. And I know there's a very abbreviated answer, but we're going to get more into this probably, I think, in our third session on MSTP versus IP and network architecture. Anything to add, Grant?
Yeah. So that was a great answer. This is allowing you to, with these switches, it is really allowing you to build out a lot bigger and more extensive network than what you would typically have. You're no longer concerned about the location of your building level controller, which is something with the older MSTP networks you would be. You need to be able to tack on to the end of that daisy chain, like what we have over here. This daisy chain, you need to find a way to get access to that, or go all the way back directly to the building level controller to run your communication link. IP definitely has a lot of advantages. We'll hit on that a lot in the third session.
Great explanation. So let me see. Okay. Are your VAV controllers linked together, or do they work independently from each other based on what equipment is operating?
So what we would like to see is to have all those VAV boxes and the air handling unit that's serving them all be networked together on a BAS system. With that, you're going to be able to do some certain system level functionalities that you wouldn't be able to get with them all being standalone. That main one would be fan pressure optimization. So with that, you're able to ramp back the energy intensity of your fan, not run it as hard, and drive open VAV boxes a little bit further as needed, so that you're really optimizing that system. So networking stuff together as you do with the BAS system offers those advantages, whereas if they were standalone, you wouldn't be able to do that.
Got it. Okay, we have a question about factory package controls. And it looks like the question is, do you mean the question's a little bit hard to interpret, but just clarification on what we mean by factory package controls. But typically when we are talking about factory package controls, we're referring to, like, say, a rooftop unit or a piece of equipment that comes with its own controller. Oftentimes there's also like internal sensors that will be wired from the factory, and in which case really all the controls contractor has to do is bring one cable, like a Cat5 or Cat6 cable if it comes with that BACnet IP connection, or if it comes with an MSTP connection, then you're bringing just one connection and you're done. But as Grant alluded to earlier, you know, you got to really read the documentation carefully, because sometimes there are some field installed sensors and wiring that you need to do. So factory package controls, it can mean everything from fully packaged, just need to bring one cable to it so it can be tied into the BAS, or it could include some other things like field mounting and wiring sensors.
Yeah, yeah, or maybe it doesn't come with the valves, or it's really hard to know what it's coming with without doing that pre-coordination. And unfortunately, every equipment manufacturer provides different things, so it's not consistent across the board for fan coils. Depending upon who you're talking about, they each could provide something different, manufacturer to manufacturer.
Mm-hmm. All right, looks like we got a lot of questions on BACnet IP. Maybe we can answer some of the basic ones and just make sure folks attend the next couple sessions on communication protocol and IP versus MSTP. But Grant, maybe you can take this question. What's better, MSTP, BACnet over Ethernet, or BACnet over IP?
So we're going to really immediately knock out the over Ethernet one. That is definitely not an option you want to look at. You're running it. You can run into a lot of issues with that older style communication. It was only around for like a few years before BACnet IP took over. So now comparing between BACnet MSTP and BACnet over IP, you definitely, for any new installation, you should be using BACnet IP. There's no questions asked about that. If it's a new installation, there's no existing infrastructure to build off of. BACnet IP offers the security and the speeds that are going to carry your control system for the next 15 years, however long you have that control system installed for. That's one thing people kind of forget about, is how long these systems can remain within a building. You don't want to go with an MSTP system that's likely already 10-plus-year-old controllers that maybe seen a few minor updates. The IP product lines are definitely the newer ones with every BAS manufacturer.
All right, here's a really good question. What could be used for a quick cost estimate? Is it price per point? What does that price include? Programming, commissioning, profit? So I guess I'll start to take that one. I mean, each market is going to be so different. Grant's in the New York City market. I'm in the California market, which are going to be more expensive than probably other parts of the country. So I'd say it's very specific to your market, and your local building automation contractor or systems integrator could probably easily give you budgetary pricing, either based on points or system. Like a simple air handler, a complex air handler, probably have a really good idea of like cost per VAV, or per zone, something like that. But usually it's a combination of, maybe system, maybe square foot, is it commercial office, is it a hospital, points. So I'd say usually kind of based on experience, somebody local would be able to give it to you based on all of those factors.
Yeah, I would say steer clear of the cost per square footage. That's very, very variable.
Yeah.
I should have said very so many times. That just really confused that. But yeah, it's the cost per square footage is really tough to align with. Whereas something like I typically do cost per point and can build it up that way, starting with my electrical and then adding in the controllers and control devices from there. But everyone does have their own method to the madness. So I'd say work with your local controls team to better understand budgets up front on projects. I think it'll save you a lot of headaches on redesigns if you understand where the budget is at with a pretty accurate budget during the design process.
All right, here's a good question, something we haven't touched on yet today, but do most projects utilize external 3D graphics or animations or inbuilt graphics provided by a library?
I would say most controls manufacturers at this point have it in-house, or I would say most they have a dedicated team towards doing graphics. There are a few that kind of do things differently. Distech, we do have options available to do both in-house, or if specific contractors want to take that task on and get graphics from any graphic shop, they can work with that as long as those have mappable points.
Good answer. All right, where does lighting controls lie in controls basics?
So I don't have a session on lighting controls. I've been considering maybe building out a few more topics to build into lighting controls and how that would interact back with the BAS system. I think it is a great topic. Between HVAC and lighting, they are your two highest consumers. I will say Distech does have I'll label some advantages in that front, being that Acuity Brands is our parent company, and they represent quite a lot of lighting manufacturers, and they're not the biggest yet, but they're pretty close in terms of lighting controls. So we do have a lot of different options available. I'll probably build out some further sessions in the future for that.
Yeah, no, just to add on to what you said, again, these sessions are focused on HVAC controls. However, lighting controls, a lot of times what we'll do is integrate to lighting control. So typically within these lighting control systems, these different systems might be essentially proprietary up until like their gateway or like master controller level, in which they become, in an open protocol like BACnet. And then you can either pull in those points to be able to view them, maybe turn zones on and off, dim the lights, things like that. But we're going to talk a little bit later, again on Thursday, about open systems, a little bit about BTL listings. But in terms of integration, I love a matrix of responsibility in the specification, because it can get sticky when you're talking about dealing with another trade, such as lighting control, which is installed by the electrical contractor, as well as just doing your due diligence and making sure that that lighting control panel or gateway, you understand its capabilities. Are you able to only read certain points, or are there also read-write properties which give you kind of control and command capabilities?
Yep. So one of the final questions, in terms of receiving the deck, we will be following up with a thank you email for everyone that was attending, that will have the PDF deck of the PowerPoint.
Okay.
Awesome.
Good questions. We had, I can't believe there's still 100 people who have still stuck around for all these questions. So let's see.
Thanks. Yep.
All right. Well, thank you guys so much. I don't think we still have a long list of questions here. I don't think we're going to get to all of them today, but you can reach out to us or your respective Distech Controls regional sales manager for follow-up and any other specific items you might have.
Awesome.
All right.
Thanks everybody for joining, and we'll catch you on Thursday.
See you Thursday. See you guys.